Okay, so I think we are all here. We can start our webinar. Today's session, we're going to talk about solutions for hydrogen control in the steelmaking. What is the benefits of the solution? Why do you have to control the hydrogen in the steelmaking? And what are some of the available options that we have for doing that? We have with us our specialists here. That will bring this presentation to us with a lot of content. We have Pablo Santucci, NAFTA Technical Sales Manager, our currently NAFTA Technical Sales Manager, but he was the former R&D manager for this hydrogen solution. He was working on the development of the solution in the beginning. And we have also Carlos Vicentini, who is our current Global Product Manager and a Global Product Application Manager. And he's also a big specialist in the solution, and he understands a lot about the hydrogen system, about the sensors, and he will be bringing a lot of knowledge to us as well. I am Pedro, the Global Marketing and Sales Specialist for Vesuvius Sensors and Probes as well. I will be the facilitator of this session. This session will be with the duration of about 1 hour, which will be more or less 40 minutes for the presentation itself, and we will have another 20 minutes for questions and answers. Please, you can address your questions and answers in the chat. We request that please you keep your microphone off, because sometimes you forget it on and make some noise and everything. So we can avoid that. Please keep the mic off and address the questions in the chat. We will be very pleased to answer them in the end of the session. And also, I would like to remember that this session is being recorded and that we will be able to share this content in our channels and platforms in the future. We will be getting them to you by email. Either we will have this available in our YouTube channel. If you don't follow your YouTube channel yet, please, you can go ahead and follow us on Vesuvius Digital Services. And so we can start now with our presentation. I would like, please, also to that our presenters can introduce themselves now. So please, Pablo Santucci.
Hello, everyone. My name is Pablo Santucci. Just like Pedro just said, right now I'm the NAFTA Technical Sales Manager, but I also have worked for our Vesuvius Sensors and Probes plant in Brazil for 20 years in our R&D department, where I got the opportunity to join the team and develop this hydrogen solution for our customers.
Thank you very much, Pablo. And we also have Carlos here. If you can please present yourself.
Hello, everyone. My name is Carlos Vicentini. I'm responsible for the engineer department, the application engineer department. I'm here at Vesuvius for more than 30 years, working directly on the plant in the quality department. After that, in sales. Right now in engineering, with more focus to support sales in the application of the products.
Okay, thank you very much, Carlos. And I would like also to thank all of you, our audience, everyone that's being here. We had more than 100 registration from all over the world, and we have more than 60 people around attending here. I'm sure that there are some people joining us, and I would like to appreciate your presence here, and I'm sure that it will be a great exchange of knowledge. So we can start with the presentation. First, with the video that will present our division.
Vesuvius is a global leader in molten metal flow engineering and technology. We think beyond today to create the innovative solutions that will shape the future, delivering products and services that help our customers make their industrial processes safer, more efficient, and more sustainable. Our more than 11,000 strong team delivers solutions to customers in 40 countries across 6 continents. From our 55 production sites, 68 sales offices, and 6 R&D centers of excellence, delivering excellence. As a part of this global group, our Sensors and Probes division delivers complete and customizable solutions to precisely measure the many variables involved in the production and treatment of molten metal. We focus on providing a range of products that enhance the control and monitoring of our customers' production process, complementing Vesuvius' strong presence and expertise in molten metal flow engineering. We create technologies that can be integrated into process management systems and products that include temperature sensors, oxygen, hydrogen, and sublance probes, and iron oxide and metal sampling systems. Our products are carefully designed, tested, and fabricated to increase the efficiency and sustainability of our customers' processes. We supply melt shops and foundries all around the globe with high standards and service levels. With our global team of highly qualified professionals, Vesuvius Sensors and Probes is constantly evolving our product development processes and innovative solutions for customers around the world. We have operations on all continents with production and assembly facilities in Brazil, Italy, the United States, Mexico, and South Korea. And we have commercial or administrative offices in Canada, Argentina, Chile, Turkey, France, and Germany. This global presence enables us to bring the same level of service excellence, specialized assessment, and technical support to customers in every corner of the world. Our commitment to meeting the needs and expectations of our customers ensures we pay attention to every detail, from service to final delivery, in all stages of the process, to guarantee the quality of our products. Vesuvius' core values of courage, ownership, respect, and energy unite our colleagues and underpin our commitment to our customers. They are the guiding principle that inspire us to constantly innovate, to never be satisfied, or accept second best for ourselves or our customers. And our overriding commitment to health and safety is embedded throughout our organization. We are committed to protecting the health and safety of employees, contractors, visitors, customers, and everyone affected by our activities. Nothing is more important. As part of this, we work very closely with our customers to improve safety on the shop floor. And Vesuvius colleagues and teams have received recognition from many of our customers for the contribution they made to safety on site. We want to be a zero-accident company and are striving to become a best-in-class organization for safety performance and leadership. Our purpose is to help our customers make their industrial processes safer, more efficient, and more sustainable by reducing their environmental footprint and CO2 emissions. Our R&D and product development is focused on products that deliver better results, more efficiently, and with less environmental impact. Our global footprint means we are a diverse company, but we're not satisfied with that. We truly believe that better ideas come from broader backgrounds and that an inclusive culture can generate more possibilities, productivity, and evolution, contributing to a more just, inclusive, and dynamic society. That's Vesuvius Sensors and Probes. Think beyond, shape the future.
Okay, thank you, everyone. So after watching this nice video introducing the Sensors and Probes division, we can jump into the presentation. So please, Pablo, you can start.
All right. Hello, everyone again. So just to give you a heads up, in the next couple of slides, we're going to see and show a little bit what was the main cause of having hydrogen inside of the steelmaking process and how it's important to monitor or tracking that across those stations. So basically, the steel industry tends to track hydrogen across its process due to two main different facts. One is to avoid continuous casting breakout, and two, according to their customer requirement in terms of chemistry, they tend to get hydrogen content under certain levels so that they can avoid application problems, as we are seeing this in these slides. So this is one of these examples that how critical is the hydrogen presence inside of a steel structure or steel chemistry, because that can provide many different problems in relation to hydrogen presence, because it can provide premature failure of the steel structure due to porosity that is being built up inside of these steel grades. So you have 3 or 4 different pictures in your right-hand side, what proves how problematic would be a hydrogen presence inside of these steel grades. In the next page, if you can go. Yeah. In the next page is just another example how critical could hydrogen be inside of continuous casting machine. And just like everybody in this webinar knows, that can also provide a breakout issue during these continuous casting processes due to a higher level of hydrogen inside. So consider these main 2 facts of hydrogen presence inside of steel making process. We can determine that the max hydrogen level accepted in this continuous cast machine could be around 6 ppm, 7 ppm, so that these elements will not provide a major problem or major risk in this process. Whereas in the previous slide, when customers, steel mill customers, requires a chemistry spec, and normally in order to avoid any fragilization in this steel structure, there are some steel grades should be controlled under 2 ppm. So this is the main scenarios that we can consider when we are tracking or monitor hydrogen across the steelmaking processes. And Pedro, could you go to the next slide, please? Yes. And based on that, this is a Pareto analysis that has been made for a long time that can shows the main top offenders or the main causes of hydrogen presence in this process, in the steelmaking process. For instances, we can have hydrogen source due to atmospheric conditions. For example, scrap can get wet in the rainy seasons, or the humidity of the atmosphere is too high. That can contribute to having high hydrogen content inside of the steel. Not only, but water leaks, for example, in the EAF stations, can also contribute to get this pickup of hydrogen inside of the steel. And that's some other factors that can also contribute with this pickup element, like type of slag, or depending on the carbon charge or alloy that has been put inside of the steel during this process, can also contributed with this hydrogen pickup. Next slide, please. So based on this scenario, what Vesuvius has done is to develop a new hydrogen system and solution for allowing our customers to better monitor hydrogen across their processes. So basically what we have it here, as you can see in this slide, is the working principle of our unit or our entire system that not only consisted in pneumatic cabinet, which is being supplied by a nitrogen source, but also this system has been connected to our disposable probe, what goes inside of the steel, as you can see in this picture. So it's just a representation of the ladle, of course, but that can represent how our probe will work inside of the steel. By the time that our system starts to purging inert gas, in this case nitrogen, through its channels, because we have two different channels, one that goes toward to steel molten metal, and then purge nitrogen inside. That being said, this nitrogen will be combined to the gas inside of the steel, and then this gas from the steel can be sucked by our ceramic bell, which is built in our probe. What then will be filtered and then measure its thermal conductivity. Okay, so this thermal conductivity will be measured by our TCD inside of the cabinet, and this TCD will be able to get the thermal conductivity difference between our inert gas, which is nitrogen, and then compared to the gas mixture that has been measured or bring from the steel. All right, so moving forward, this page is just a cross-section view of our disposable probe, which is basically responsible for separating the mixture gas that has been collected from the ladle or molten metal to the molten metal itself. So the main purpose of this disposable probe is having this gas filtration so that we can keep in recirculating for X number of times the gas mixture through all of this system. So from the molten metal to our pneumatic cabinet. So that help us to find out the best equilibrium and determine the best hydrogen level at the end of the measurement. Can you move ahead, please? Yes. So at the end of the measurement, our customers will see this main display, this main screen, what tell them the exact moment where our system were able to capture the hydrogen reading. So in this case, it took 36 seconds, and we got 4.6 ppms of hydrogen, dissolved hydrogen inside of the steel. And there are also some other features that has been displayed, such as the pressure curves, where you can see the blue and purple trace. This also help us to identify if an eventual reading has been worked well, or perhaps we have any clogging inside of these pneumatic channels. And you can go ahead, please. Yes.
Mhm.
So in a more detailed way, it's good to understand and explain to you guys what has been made in this case. So as you can see in your left-hand side, we have a graph with these two traces. So red is the actual hydrogen reading, whereas the purple and blue ones are the pressure traces. But not only, inside of these 36 seconds, we have some preliminaries purging or flushing periods, what help us to guarantee that our system will be clear out and not having any influence from atmospheric residues inside. So it's important to give us this appropriate time for flush periods, as we call flush A and B, so that we can provide the cleanest environment to our system prior to start to collecting the data. And then during this measurement time, it takes probably another 24 seconds to reach out an equilibrium until the end of the measurement. Thank you, Pedro. You can go ahead.
Mhm.
So these parts covers the working principle of our system, but not only, it's also recommended that we proceed with the best practice so that we can guarantee that our reading will be in the good conditions and have no problems during the measurement. So one of the good practice recommended from Vesuvius side is to guarantee a perfect immersion and angle for the same immersion. So make a long story short, the optimum immersion procedure would be a probe being immersed inside of the steel as vertical as possible, and also having an immersion depth around half of our no splash sieve until max 3/4 of the same reference. So that can be considered as a good immersion depth and angle. So that can prevent many problems during the immersion and avoid a false reading during the measurement. And here is another good practice that we also recommend, which is consider the Siebert law for these hydrogen readings. So Siebert law is basically what tells us which element can contribute or not in terms of a hydrogen pickup during that measure. But not only, the Siebert law can also consider the actual temperature of the steel as well as the referred immersion depth of our probe. So all of these factors can contribute to a better and optimum hydrogen number right after the measurement. So this is not anything new that I have been introducing this page, but this is something that we also consider in our equipment based on the theory for steelmaking process as well. Okay, Pedro. In order to make all of this theory a little bit more faster and easy to be applied inside of the steel making process, we also have a interface where we can get all of those data that you're seeing in this screen, which is current temperature and chemistry of a new steel grade or heat being take new measurement into account, and then get a communication between our system to our customer level 2, so that this level 2 can previously inform our system about those information, temperature and chemistry, so that a new KF factor can be calculated and then being considered into account for the next hydrogen reading. So that helps the steelmaking process to, once again, find and determine a more accurate hydrogen value at the end of the measurement. And once we get these new feature set up between our equipment and customer level 2, all data has been loaded automatically. So no more manual inputs will be needed afterwards. Okay, so this is a part of our maintenance and service recommendations that we do and we offer to our customer. Sometimes customer prefers to have this maintenance procedure being made by their local team, or some others do prefer to hire our local service to do that maintenance or checks. I would say that it's more a matter what customer prefer. But in those next page, you're gonna see some topics, important topics that is being recommended for keeping our equipment in a good level of quality, so that the readings will be 100% guaranteed. Okay, so basically, service can take 3 or 4 hours on every single visit, just depending on how many different procedures will be required upfront. Next page, please. So first of all, the calibration procedure is a mandatory procedure that has been taken into account for our equipment, so that we can assure that the results afterwards will be under spec. So this is not say a demanding or tough procedure. It takes around 5 or 10 minutes, depending on the equipment's being located. And in addition to that, we consider calibration gas for running this calibration procedure, which is a mixture of gas by considering X amount of hydrogen in nitrogen balance. For example, in this case, as you can see in the graph, 3.0 ppms dissolved hydrogen in steel means that our calibration gas used for reaching that number 3.0 was 1.5% of hydrogen in nitrogen balance bottle. So that's what the theory says in terms of reference for calibration. And the frequency of this procedure depends from customer to customer, but I would say for most of the guys in South Hemisphere where room temperature will not change much, you could consider calibration procedure on every 6 months, whereas countries or plants in the North Hemisphere where the room temperature tends to change a little bit more, I would say on every single season. So on every 4 months, 3 months, it would be recommended. Next page, please. Not only calibration gas, but also checking the leak of the entire system is also recommended, because any kind of leak can and will influence the final readings of our system. So keeping a perfect sealing in the entire system is the best. So every time that a part needs to be changed, for example, a lens or a pole or a hose inside our system need to be changed, it's also recommended, highly recommended, that a leak test must be put in place so that once again we can guarantee there's no leak being built afterwards after this swap. So, but if there's no parts change, I would say a good frequency for doing that check would be once a week. And in this case, the leak test can be checked in many different points of our system. So a leak test can be made at the end of the pole, in the hose, or at the back, bottom part of our entire cabinet, pneumatic cabinet. Next page, please. Yes. So based on what I said in the previous slide, this is just a example how such leak test has been made in our system, so that the system consider the time zero, or the initial blow pressure in the time zero, and then after 30 or 40 seconds later, it also consider a second blow pressure, where you can see in the middle of this screen. So the difference between time 0 and time 1 will tell us the pressure loss, or the leak itself. So any level lower than 25 HPA, or for some of those of you that's not familiar with that unit, 25 millibar is a good number for determine that the system is okay to take new readings. So higher than that, the system requires a new action and check if there's a leak in any part of the system. Next one. And last but not least, there is also an air simulation, what give us some ideas in terms of functionality of our system. So this is designed for a very quick check when people from our customer operation needs to get a check and see if everything is running properly in this system. So by the time that the operation get one of those two tools into account, they can simulate, or actually take also a probe, a real disposable probe at the end of the pole. Operation can run a simulation and see if the system has been working properly. So as a final hydrogen value expected right after this step would be around from 0.8 up to 1.6 ppm. So that tells us that the system has been working properly depending on the customer conditions. I would say room temperature and current humidity around it. And here is another recommendation that we would like to emphasize, which is related to our filters inside of the system. So the frequency on how this should be changes would be around 150 measurements, or anytime that people or operations see that filter element, as you can see in the bottom corner, right hand side, as in dark color. So that requires a change in this case. Well, lens is another critical part of the system, because if this change will not be made in a proper way, that can provide a source of leak, and in this case can gives you a false reading. So according to our experience, we have been faced many times with a no proper lens check, lens change, and most of the times people don't follow the recommendation, don't take any leak tests after a lens was changed. So that can also provide a source of leakage, and then there's no guarantee on how hydrogen readings could be assured in this case. So once again, lens repair or lens change needs to be followed with a leak test afterwards.
Okay,
Next
just before jumping into the next slide, I would like to remind you guys that we are reaching now the approaching the end of the presentation. So please, you guys can start asking your questions. Everyone who wants to make a comment or want to find out more about the solution or have any questions, please feel free to type it in the chat, and we will answer them in the end of the session, please. Okay, please, Pablo, go ahead.
Yeah, here is our just a demonstration of our hose. That hose for our hydrogen system just being developed for connecting our pneumatic cabinet to our lens, and it's just an extension of our pneumatic channels towards the lens. So, but once again, some precautions needs to be taken into account every time that a new hose, what is being put in place, needs to be put in place, needs to get a leak test afterwards as well, so that once again we can guarantee a perfect sealing through all system. Next one. Yeah, I think that's it. We reach out the end of the presentation. So at this time we are open for Q&A session, questions and answers. And I would like to thank you everyone for joining the meeting, joining that webinar, and we're open for questions.
Yes, I would like to thank also everyone, and I would like to thank also our presenters, Pablo, Carlos. Thank you for your time. Thank you for sharing with us your expertise, and thank you for everyone that are here for our audience. And now we will start with the Q&A. I will just read the questions and then I address to each of you, like any of you who would prefer to answer these, or if someone wants to answer, the other can have comments and we can go like that. So first of all, we have a question for David Patterson. Thank you for your question. He's asking what quality defects would appear in steel casting due to high hydrogen? Secondly, can slow cooling of castings dissipate the hydrogen from the castings?
So the answer is yes. In terms of quality defects that can appear in the steel casting, is probably the immediate containment action for that would be a slow speed of this continuous casting machine by the time that they reach out high levels of hydrogens. For example, if a certain steel mill tends to control the continuous casting machine hydrogen up to 6 ppm, and they suddenly get 7 or 8 ppm in the next heat, they will probably slow down the speed of the continuous cast so that they can avoid this breakout. And afterwards, it would be a kind of steel make plant decision to reprocess that steel that was being casted or not, or use or reclassify that.
Yes, just to complement the answer, we also receive some reports from our customers that when you have a hydrogen pickup in some steel after the solidification of the steel plate, the steel slab, or depends on the casting, the hydrogen can cause some cracks or some defects in their final product. So the better control is very important.
Yeah, and of course there are also some options afterwards. They can reprocess this slab or whatever size of steel or format of steel you're gonna have it, but it's costly. It's a reprocess, so it takes time. It takes more money to be invested. So just like Carlos said, it always recommended we would be proactive in that regards than take the actions after the fact.
Great, thank you, David, for your question. Thank you, guys, for the comments. So next question is by Tulio. Can N2 line be used with Vesuvius instrument or just a nitrogen bottle, or just an N2 bottle? I think about the calibration.
Yeah. We really recommend to use the bottle. In fact, the bottle or line gas, it's not a big problem. The question is the purity. To measure to take good measurements in terms of hydrogen, it's very important to use a high purity nitrogen as used as a base of the measurement. And usually, if the steel mill has a good tubes and a good line in terms of guarantee the purity, when they enter in our system, no problem. But it's not easy to take this purity when you use the inline nitrogen. So we recommend to use the bottle because it's more guarantee to keep the purity very high to use it during the system measurement.
Yeah, and just to add some more comments over that question, the minimum purity recommended from Vesuvius side is 99.97% dry and clean source of nitrogen. So by the time that customer can guarantee that their nitrogen line installed or installation is good to go under that requirements, I don't see any major risk, but always bottles is more, I would say, guaranteed in that regards because it's a sealed container, so and certified.
Great. Thank you guys for your comments. Thank you, Tulio, for the question. Now we have another question from Gregory Marchand. How does hydrogen pin measurements compare to the system? Is there a separate webinar or any expertise within Vesuvius around pins?
Thanks for your question, Gregory. And the answer is yes. We have done that already, and there is an interesting comment in that regards because pins, if I understood you well, the pin analysis comes from LICO devices, what consists into taking pin sample and then keep that sample under certain conditions, nitrogen, liquid nitrogen, until it's gonna be treated, finished, and then cut it for leak analysis. And our experience is that we do have good correlation with the pin results. However, as I could see in the past, if you can get let's say calibrated reference from LICO device, and depend on the range of hydrogen that customer is being spec, the uncertainty of this standard from LICO is higher than, or tends to be higher than 50% of what customer is being running or is being monitored. I'll give you some examples. So let's say that a steel mill tends to get hydrogen under control lower than, let's say, 1.6 or 1.7%. This LICO standard for hydrogen is being certified as 1.0 plus or minus 0.3 or 0.5 ppms. So it's too much. But we did that analysis and comparisons in the past, and our results were pretty good, plus or minus 2-3 ppms on average in comparison to their average pin results.
But it's very important to highlight the procedure to compare these results with the pin is very restricted. Of course, as you know, to take this sample by pins, by vacuum pins, demands a lot of cares. So to avoid the contamination and pick up your hydrogen, usually when you run, for example, a trials or tests with pins, if you check the repeatability. Basically, you don't get good repeatability with pins because affected especially by the procedure, because this procedure is very, very restricted. Okay, of course, our system is more robust than avoid this kind of pickups during the measuring process.
Okay, excellent. Thank you. Thank you very much, Greg, for your question. And thank you, Pablo and Carlos, for the comments. We follow here with Wolfram question. What a critical minimum hydrogen contents in low alloyed steel melts measured with your device?
Well, I would say the very minimum hydrogen, I mean, and I'm talking about minimum range that our system can read is 0.5 ppm. So that's the very, very minimum range for hydrogen from our system.
Again, it's very important to highlight also that when you are talking about within the 0.5 until 1 ppm, we recommend engineering following, because we needed to make some adjustment in the equipment to specific to this restricted range. Okay, of course the system is capable to measure it from 0.5 ppm until 15 ppm, but regularly we recommend you to as much restricted this range as possible, or calibrate, check, liquid tests, etc., etc. Pablo showed us during this webinar is better accuracy you can take from the system.
Okay, great. Thanks. Thanks, Wolfram, for the questions. We follow with Vanderlei. Marcos is asking, the inert gas could be argon.
The answer is yes, it's possible, just because the thermal conductivity of argon is very similar, but once again, not the same in comparison to nitrogen. And both of them, argon and nitrogen, has a thermal conductivity too different in comparison to nitrogen. So that being said, argon can be used. However, our system has been calibrated in our manufacturing site by using nitrogen. So every time that a new request like that is needed, we need to recalibrate our system based on argon, and use argon as our carrier gas for this specific unit.
Excellent. Thank you, Vanderlei. And now Wolfram is asking, how is the compatibility between measurements with air probe and heat extraction measurement at solid samples?
That's heat extraction measurement at solid samples. I don't know if I could understand you properly, Wolfram. I would ask you to confirm that or not. But once again, consider solid samples. The only comparison that we have been made so far was the pin samples, the vacuum pin sample, what needs to be put it in a liquid nitrogen. So if that's your question, the answer is yes.
We had another information. I don't know, some one customer, for example, made some comparisons in the past, but just in terms of defects in this in their product. Okay, they check according to our measurement how many defects they can find in their products. So they, for example, they establish a limit that to find in the end product or the finished product, they can accept when you take measurement below this limit. For example, this is another report we received from a customer here in Brazil.
Okay, thank you. Great. And the next question is by Agatha. She's asking, which secondary refining stations can receive hydrogen measurement?
Basically, all of those can receive a hydrogen measurement, but just take into account that it would be worth it if you could get these hydrogen systems installed after degassing treatment, for example. So any degassing stations, which could be RH station or VD, could be an option, so that you can treat your heat or steel prior to take any hydrogen readings. So that what makes more sense to your could make more sense to your process. But in the real world, any station which is being considered a ladle in use, we can take the hydrogen measurement from there.
Another good example that you can mention here, for some customer, for example, we has our system installed in ladle furnace and also RH station and also the caster. So the customer can following the hydrogen content in different stations to check if the processes are working properly. It's possible.
Okay, excellent. Thank you. Thank you very much, Agatha, for your question. Thank you guys for the comments. Now we go to the next question by Roberto Yanis. Roberto Yanis, when using plant N2 versus bottle N2, can there be a difference in hydrogen ppm? Is this due to possible contamination? I think it's what you guys.
Yeah,
Right.
the answer it could be a yes, Roberto, just depending on how frequent have you been getting those ppm difference. Let's say that you're getting a monitoring the hydrogen back to back and say, hey, I'm gonna take one reading from a hydrogen system purely connected directly from plant line, nitrogen line from the plant, and another one from the bottle. If you're gonna take these comparisons back to back in an extensive time, and in case this difference still persists, I would say that it's possible a contamination in the nitrogen line from the plant, because the nitrogen tank, it's already certified and and comes with a high level of purity.
Yeah, another possibility, Roberto, is when you can take it too much variation, for example, especially when you're talking about the steel that we have a good process procedures that usually they use it their metallurgical prediction, metallurgical method to treat this steel, and when they take the measurement, they can check it. There are some variation within a back-to-back or within 2 or 3 comparisons. So usually, if they are using the line nitrogen, could be the cause of this variation. Okay, when they, for example, we receive a feedback from one customer some time ago that they can take this variation. Then we recommended them to change from nitrogen line to bottle, and also they can stabilize the variation the regular way. Okay.
Okay, thank you. Thank you very much, Roberto, for the question. And thank you, Carlos. So now we already passed a little bit of the time. So I think we're having now the last question, and then we can end the session. But I appreciate very much that this is a very constructive talk, and I appreciate all of your questions, guys. So the last question that we have from Michele is a great question. Actually, all of our questions were great, guys. But it's, what are the types of customization that we can add to this solution?
Well, I mean, we along of 11 or 10, yeah, I would say 12 years time after we have developed and launched this equipment and solution, we didn't receive a lot of customization requests. However, from time to time, a customer or another tends to ask for a short lens or a short probe, so that this new design can fit inside of their application. But outside of that, lengthwise, we have not been hearing so many customization requests. So most of the time it's being related to length, or sometimes customer are more sensitive to take a hydrogen reading at the caster by using a sand sleeve in our probe, and then they request a more inert sleeve, such as no splash sleeve with ceramic fiber, fiber ceramic sleeve, and that in that regards, we can do and we can supply them without any problem.
Yeah, but it's very important to understand that when you're talking about customization, as according to the Pablo's explanation, is in terms of basic function of our solution. When you're talking about, for example, the equipment, the lens, or the probes. But when you're talking about, for example, we help a lot of customers to change, for example, from manual immersion to automatic immersion. Of course, we can help the customer to customize this application, including because to take this good measure, the time is very long, within 35 seconds until 65 seconds. So a lot of customers request us to help them to propose some automatic measurement, for example, or if you have some difficulty to immerse our probe more vertical as possible, we can also develop some different lens with different angles to better fit this application to help the customer to make this immersion more vertical as possible according to our recommendation. We also can make a small changes in the software to better communicate, especially in terms of level 2. We also can receive the KF calculation when they use the alloy compensation automatic in their level 2 to read by our equipment to use this to improve the accuracy. This is some examples that we can help the customer to customize that, not just the measurement, but the application and the good procedure that we usually recommend to take this measurement. Okay, this is basically the customization that we offer in terms of solution.
Exactly, and it's good and it's nice to emphasize that we have our team of specialists here who is ready to assess you and to assess you with all your needs. So anything that you need and anything that can come up to your mind that you would a solution that you could find within your process that you could find helpful, come reach to us and our team of specialists. Engineers will understand your needs and try to come up with a solution and try to find out some of your products that can help you and how we can assist you within all that. So it's everything about understanding the needs and working together to find a solution. So we have one last question. So I think it's Michael Madden is asking. It's a very quick question, so I think we can answer this and then we can end the session. So how can immersion angle affect the reading and why?
Well, the optimal, just like I said, Mike, the optimal immersion angle would be 90 degrees or as vertical as possible, and there's a reason for that. Imagine that you have this pen here as being the hydrogen probe, and the bubbles that being purged inside of the steel goes to its ends like this. If you purge and don't have these 90% degree, the bell, the ceramic bell, could not be covered or could not be surrounded by the air, or by the gas, by the nitrogen. So it's kind of impossible to recollect the mix of gas right after we purge the nitrogen inside of the steel. So that's why by the time that they keep doing immersion like that, the nitrogen purge goes in that direction and goes away as vertical as possible. So that's why you have to keep your probe in this orientation, so that by the time that the nitrogen has been purged, it go down and surround the bell, the ceramic bell. So that make possible the capture of mixture gas. from the bell.
Yeah, including this kind of orientation that Pablo mentioned, avoid some fails, especially fails, to create, for example, cloggings around this bell. Due to this is a good practice that we really recommend it to take. Okay.
Okay, great. So thank you, everyone. Thank you, Carlos. Thank you, Pablo. I think we can finish here our session. I would like to say that it was a very interesting, very constructive debate, very constructive with a lot of knowledge, and I appreciate everyone's presence here. And thank you. And in the near future, you will be receiving the recordings and all the material around this session as well, this webinar. And thank you very much. You guys.
Thank you, everyone, for being participating in this session, and thanks, Pedro, for the organization in this webinar.
Thank you very much. And if we can support you, don't hesitate to contact us. We all the time are available. Okay. It was a pleasure to contribute to this very good session. Thank you very much.
Thank you very much. Bye, guys.
See you next time. Thank you.
See you next time.